Hello, good day everyone, and welcome to this week's Inventor Make It Snappy session. You are here with Yashin from Modern OneSolve, and the feature that we will be highlighting today is the sheet metal face tool. Now, before we actually get to the face tool, I'm going to show you how, or one of the ways to access the sheet metal environment. This can simply be done through your Inventor home screen by toggling the new document option. This will then open up your predefined or default templates that come along with Inventor Professional, and you'll see that you have a sheet metal standardized template. In this case, I'll use the millimeter IPT and select create. Now what this is going to do is take me directly into the sheet metal environment, where I will have access to all the nifty tailored sheet metal tools that can be used. Now what you'll notice is that most of the tools themselves are grayed out because we actually need to start this process with an initial sheet metal base profile or shape. To do this, I will have to create a closed loop by defining a new sketch on the XZ plane and creating a closed profile. This is of course going to define my base of the sheet metal part that I'd like to create, which will be 400 by 200 millimeters in size. Once that has been created, I'll exit the sketch environment and I've got something to work with now. Now of course we like to transform this into some form of material, okay, essentially extrude it, and that's where the face tool comes in handy. Once I start the tool from my ribbon, the dialog box will open and a couple selections may need to be made, such as the profile. In this case, Inventor has automatically selected the profile for me because it's picked up that we have only one available closed profile to use, which is that rectangular sketch. Now if I zoom into this profile a little bit more, you'll see that the preview is adding material to the top. So this material being added is the default thickness defined by what we call a sheet metal rule. The sheet metal rule defines the type of material, the thickness, as well as some of the bend behaviors and some of the additional sheet metal tools that you can use. So this conforms to some form of standard. Of course, we don't want different types of thicknesses in one component because the sheet metal part is going to be cut from a standardized sheet metal plate itself. So this kind of limits you from making any of those mistakes. Another thing you can do from the face tool dialog box is change the direction of the material, very similar to the directional options available in the standard extrude from the standard part environment. So in this case, the material is going towards the top of my sketch. I can toggle these directional buttons to move it in either direction, okay, below my sketch, or alternatively symmetrical about either end of the sketch profile. Once you've made the correct choice in terms of the direction of your material, you can simply select OK, and we'll have a base feature 0.5 millimeters in thickness as defined by the sheet metal rule, and this will allow us or give us access to the rest of the sheet metal tools available in our ribbon. Most of them are active, which means we can use things like the flange, cut, hole, or any other feature to generate our sheet metal part. So that pretty much summarizes the sheet metal face tool. Stay tuned to our YouTube channel to check out how we use some more of these tools and functions.